This is my moment of inertia measurement system. I have a weight that is dropped using a thread, and it goes through this encoder wheel. The encoder wheel has a sensor. It's an IR sensor, and it is attached to the Arduino, and it's powered through the Arduino. That measured timestamp gets sent to the SD card and recorded. The the system has like I said, the encoder wheel, and that's on a shaft that has bearings that are in these two top blocks that hold the encoder wheel shaft. And you can see bearings in here, and there's a bearing on the other side, and then these bushings hold it in place. These blocks are fit into a piece of 80/20 like 3D printed members, and these are attached to one another using these pieces that have these joints that are 3D printed and slide into one another, and the friction holds them together pretty well. And here's a three-piece connection of these members. And then this block is fit on top of the other vertical member. Then I have a vertical member here that has a block on top of it, which supports the flywheel. And this is where I'm going to mount anything where I want to measure my moment of inertia. These pieces right here are designed so that I can put blocks of quarters as weights at distances away from the center of the shaft. I can use these these holders that hold 16 quarters, and I also have some that hold 8 quarters, and then those just slide into these pieces here. I've made these with 2 parts because otherwise they'll sag and get caught in the string. So yeah, I think that's pretty much. Oh, then there's this piece here that I constructed to hold the flywheel in place. It's in order to stop the flywheel from moving, I just slide that key up around the flywheel, and then when I'm getting ready to release the weight, I hold this down, and then it allows the member to rotate. So this just slides in here, and then I'd be ready to drop the weight and measure the times, and then take the SD card to my computer and analyze it using the Python program that I have. One other thing that I forgot to mention was that this top block for the vertical shaft has a bearing, 2 bearings. It has a bearing here, and then there's a bearing up underneath, and those are prevented from slipping down by using these bushing here and a blue bushing up higher as well. And those support the rotation of the flywheel, the place where I'm going to mount something that I want to measure the moment of inertia. Also, these pegs right here, these little pins go through the flywheel, and they hold, in this case, they're holding this mass holding structure in place. But whatever I would want to mount to this flywheel, I would do by using these holes in the flywheel, and then printing some type of apparatus to hold whatever I want to measure the moment of inertia of. I forgot to mention that the Arduino mounting board is held in place by these M4, I think they're 16 millimeter nut and bolt, which go into a part that slides in, and then there's this washer on the top, and that fixes that board, so I have one on each side. And the entire apparatus is just using a C-clamp. I've just clamped it to my bar here. The IR sensor is held in place in the same way, and it has one of these slides placed vertically there with the M4 bolt you can see going through it. And that holds the mount for the IR sensor in place. Now that IR sensor is an active sensor, and it's looking for the reflection. And this encoder wheel, the sensor is aligned with those gaps in the encoder wheel, and I have set up 18 of those around the perimeter of the wheel. I've sized those in order to get times that can be easily calculated by the Arduino that allow enough time to detect rising and falling pulses and still get some resolution about the 360 degrees of the wheel. So there's 18 slots in that wheel. I also have grooves in these wheels that I didn't mention before. So these are set up in order to make sure that the thread stays centered. And the same way on the flywheel here. And the height is set up so that this flywheel is spooling out the thread at the same height as the top of the encoder wheel. So all of those members are sized in order to make that happen. The Arduino mount uses a little breadboard that comes from an Arduino Uno shield. So I just created a fixture here that is able to hold that breadboard so that I can push my Arduino Nano into that. And then on the other side of that mount, I have a slot that is sized so that I can just slide my SD card reader directly into that slot. And then the support member here, I've just put that on for balance so that it doesn't tip over. But with the clamp here, it's not going to tip over anyway. Okay, that does it. Okay, now it's ready to go. I have no mounting hardware. Nothing is on here. It just gives me a baseline value for the moment of inertia of the encoder wheel and the flywheel. And we have the Arduino and the SD card reader all ready to record the information. So all I need to do is tell it to start. And now it's ready to go. And I am going to release the mass here. And it'll record the data. I'm releasing the key. And as soon as I release the flywheel, it'll drop and measure the information, the times. All right, here we go. All right, that's it. I'm getting ready for a test run. I have the mass hanging from the encoder wheel here. The encoder wheel is suspended by the two vertical towers here, and these shaft is on a bearing that holds the encoder wheel. Then I have the mounting hardware. Only the mounting hardware is mounted on the flywheel right now. So I'm going to get a value for the moment of inertia relative to the mounting hardware. And I'm ready to let it go, so I will reset the Arduino Nano. And it wants me to give it a name. I'm going to give it a name. once I enter into the, there we go. Okay, it's a new file, and I'll give it a start command, and it's ready to go. So now all I need to do is to release the key here, the locking key, and now it's ready to fall. And now I'll just take my fingers off of this, and the mass will pull the weight down, and we'll see what we get for the times. Okay, everything's ready. Okay. And it has reached the maximum number of counts, which is 100. So now I'll take that data file and I'll analyze that data file using the Python code.